Hello and welcome, everybody. I'm so excited to be able to welcome you all to this fireside chat that we have scheduled today with Professor Adrian Owen. I will give Professor Owen an opportunity to introduce himself in a moment, but just for the next couple minutes, want to allow time for folks to join the event, to get settled, and to be prepared for some insightful conversation around exploring brain health and talking about the recent advances and future frontiers in this space. So we will kick this off in probably about 1 minute, just letting some other folks come in and join the event and get settled in. Okay, a little bit less than a minute, but it seems that we've got quite a few participants who are probably anxious for us to get started. So a little bit of housekeeping before we get things underway, and just some background in terms of today's format. So this is a fireside chat interview style session where I'll be asking questions of world-renowned neuroscientist Professor Adrian Owen to better understand developments in neuroscience and cognitive testing and what that means for the future of this space. You are going to be able to add your questions in the question tab of this platform. You can find that at the bottom right of your screen. We will be watching that for questions, and we will do our best to try to see where there's common threads of questioning and make sure that those questions get answered with the minutes we have of this session. This interview is being recorded, and a link to be able to access the recording will be sent after we wrap. So just be mindful of the fact that you will get a recording of this, and you'll be able to rewatch it later if there's something you missed or something that you want to rewatch. A little bit of background as well in terms of who we are hosting this event. So my name is Erin Smith, and I'm the Chief Marketing Officer here at Creyos. Creyos is a solution for precise cognitive assessment that is used by healthcare providers worldwide to help them really understand more objectively how their patients' brain health is faring. It was founded by Dr. Adrian Owen, who we have here today, and it began as a series of digitized tests for scientific research that then morphed into a platform, a full service platform to help healthcare providers really get, again, a better understanding of how their patients performing in terms of cognition and behavioral health indicators. Our platform has been used in over 400 peer-reviewed studies and by thousands of clinicians worldwide. We have a normative database of approximately 85,000 subjects, making us uniquely positioned to help healthcare providers more objectively evaluate and treat cognitive and behavioral health conditions. I'm going to turn it over to Professor Owen now to give a little bit of an introduction of himself and talk a little bit about his background, and then we will jump right into a few questions that we have prepared. So, Professor Owen, over to you.
Thanks very much, Erin. Thanks, everybody, for attending. Good morning, good afternoon, good evening, wherever you are. My name's Adrian Owen. My day job is as a professor of cognitive neuroscience at the University of Western Ontario, which is in the city of London, in Ontario, in Canada. As you can probably tell, I'm not Canadian. I was born in the UK. Spent most of my life in the UK. Most of my education was in the UK. Before moving here to University of Western Ontario, I was on faculty at Cambridge University in the UK for 16 years. I am also the Chief Scientific Officer of Creyos. And as Erin already said, I founded the company about 10 years ago now, but the product as it is has actually been in development since I was doing my PhD in 1988. So it has been well over 30 years in development that has brought us to where we are today. Thanks, Erin.
Thank you. Jumping right in, let's not delay or wait. One of the things that we wanted to cover in this session was to talk about developments that have happened in the field of neuroscience and cognitive testing, and really take a look back, I guess, into 2023 to see what major and minor advancements have taken place. Can you share a little bit about what you followed over this last year, and from that, what implications or impact you think it will have in terms of measuring brain health?
Of course, yeah. I don't think anybody will be surprised listening to this that I think the area where things really took off in 2023 was in AI. Techniques like machine learning and other various techniques that all sort of come under the general umbrella AI have been and were applied to all sorts of complex data sets in 2023, and neuroscience and cognitive assessment was absolutely no assessment. As in case anybody isn't really aware, the thing that techniques like machine learning is really good at is in finding patterns in very complex data sets. So things that you couldn't normally eyeball and say, oh, yes, this person is impaired on this task. What about looking for subtle patterns of change over time or over many tasks? And that's what techniques like machine learning are really good for. Now, at Creyos, of course, we're in a really strong position to take advantage of this because you already mentioned our normative database of about 85,000 people, which is a pretty large number of people. And that is what I call a complex data set. So, of course, we've started mining that using techniques like machine learning to look for interesting patterns. And I think the big impact, where we started to make impact, is in both diagnosis and prognosis. So diagnosis, working out exactly what is wrong with somebody, and prognosis, working out what their likely outcome is to be. And I think that's where machine learning can be particularly useful. So we published a paper towards the end of last year in the journal Neurology, showing that we could use machine learning to predict outcome in comatose patients with 90% accuracy. And that's a really good example, I think, of where you could use techniques like this. This wasn't in cognitive data, it was in brain imaging data. But this was a prediction that could not be made by simply eyeballing it. The best radiographers in the world wouldn't have been able to look at this data and say, this person's going to recover, this person's not going to recover. But with machine learning algorithms, we were able to make that prediction, as I say, with 90% accuracy. So I think this will continue to evolve. And as I say, diagnosis, working out exactly what is wrong with somebody, and being very precise about their cognitive profile and how that relates, for example, to particular diseases or disorders, I think is one area where things are really going to take off. And the other is in predicting outcomes. If we can pick up subtle patterns early on in somebody's cognitive profile that will, for example, predict they're going to progress from MCI to Alzheimer's disease, or perhaps this is just a case of natural aging. I think that's something where it's enormously difficult to do in individual participants, as people listening to this will know. In individual patients, it's hard to do just by eyeballing the data. But if you've got access to AI and huge amounts of normative data, then I think this is something that's going to become increasingly part of our day-to-day operations.
And then that kind of leads me into, I guess, a second question, or in a way, a bit of a follow-up question, because you mentioned AI, and obviously AI comes with collaboration with other kind of practices, other disciplines. In what ways have collaborations between neuroscience and these other disciplines played a role in advancing cognitive testing methodologies? Obviously, AI is one example, but there are other examples. What have you seen in that realm?
Well, I can immediately think of two examples. One is, as you mentioned, AI. Again, I think it's a really obvious example. Now here, it's basically methods in statistics and computer science that have provided people like me, neuroscientists, with new tools for interrogating cognitive and neuroscientific data in new and exciting ways. But that's a sort of, that's a sort of practical nuts and bolts. But on a more theoretical level, I think computational neuroscientists have started to provide us with interesting new insights into actually how the brain might actually work and how processes like memory and attention and even consciousness are instantiated in the brain. I'll give you a very concrete example. Many of you will have read about the debacle at Google, where one of their employees claimed that one of their large language models was actually conscious, and it was all in the news. This guy, I think, was fired by Google for making this claim. But this produced an awful lot of dialogue in the scientific community between particularly between computational neuroscientists and computational modelers and people like me who are cognitive neuroscientists. And that debate was really about, well, what are we going to do, when people start to think that these large language models, are actually conscious? And we had a series of meetings through last year and came to the conclusion that what we need to do is to rethink the types of tests that we use to assess things like consciousness. And I think that will be true of memory, it'll be true of attention. Once we start to develop complex systems that appear to be able to behave like humans and appear to be able to do many of the complex cognitive feats that we as humans can do, I don't think we are going to have to, at least I think this is the prevailing view in the field now, we're not going to have to start assuming these machines or these lines of code are conscious or are actually laying down memories, but rather we're going to have to redefine how we think about the brain in those terms. And that sort of brings me to my second point, which is that, the other area where I think there's been a lot of dialogue between psychologists and neuroscientists is in trying to understand how the brain is actually organized. And this wasn't just in 2023, but many of our models of brain function, and memory is a perfect example, were built on principles of cognitive psychology that are now 40 or 50 years old. And all that is changing with access to new technologies, things like fMRI, functional magnetic resonance imaging, high density EEG, functional near infrared spectroscopy, and even new methods that are being applied in animal models at the moment, like optogenetics that people would have heard about. All of these things are really starting to overturn our traditional models of cognition and starting to make us realize that actually the brain isn't built the way we thought it was built or the way we imagined it was built based on our sort of cognitive models. And I think all of these new technologies are forcing us or are forcing psychologists to rethink how the brain is organized from the ground up.
Mm-hmm. Mm-hmm. And so that's a great segue into talking about, the kind of implications for healthcare. So thinking about these advancements in technology, how has it, in the context of healthcare, impacted the accuracy and efficiency of cognitive assessment? Thinking again about that, psychiatrist, psychologist, neurologist application, are there specific innovations healthcare professionals should be aware of and starting to think about as, these shifts are happening?
I think so. And I think, obviously technology is the answer. The internet isn't new by any means, but I think the way that we can now use the internet to make cognitive assessments more accurate and more efficient, I think is really accelerating faster than any of us can follow, to be honest. Let me tell you a story. Back in the when I started developing the tests that are now part of the Creyos battery, part of our philosophy was, well, it wasn't just to take traditional tests of cognition and turn them into computerized or internet versions. That wasn't what we were trying to do at all. We were trying to take advantage of what real-time assessment could offer. One example is the fact that, when I looked at sort of traditional tests like the WAIS-R, for example, the traditional neuropsychological test, it takes 3 hours and everybody gets everything regardless of, how good or bad you are. And an obvious way to make that process more efficient is to make tests get harder for people who are good at them and get easier for people who are bad at them. And that's something we implemented extremely early, into Creyos. And it's something you can only really do on the fly with technology. You can't really do that sort of stuff by hand, and that's a really obvious example. And it does, as a result, we found, looking back over the data of over many years now, it's actually made the tests more sensitive, because you can really hone in on exactly what somebody's cognitive abilities are, rather than just have to sort of pigeonhole them as a digit span of 5 or a digit span of 6. If you do it properly and on the fly, you can actually work out that somebody's digit span is somewhere between the two. Is 5 point on average is something like 5.7. So we've applied that across the board. And the other thing that I think is also really been amazing for accuracy and efficiency is having this sort of back-end database. So again, norms, for paper and pencil tests have been available for decades, but you can't typically refer to them in real time, and very often the numbers of people that they're based upon are very small. But we're now moving towards a situation where if we want to understand the cognitive abilities of somebody like me, a 57-year-old British male, we have a database that's large enough to maybe identify 200, 300, 400 other 58-year-old British men, and we can, the more people in that database, the more fine-tuned we can make that comparison, and I can really find out how my memory, attention, problem-solving, decision-making compare not just to the general population, or even not just to the general population of men, but a very specific demographic that gives you a much more sort of finely tuned understanding of how, not only how somebody's performance is relative to that database, but also maybe how it changes over time. It makes it much easier to pick up subtle changes and these sorts of things. So we're just coming full circle to your first two questions. I think we're still at an early stage of implementing AI approaches to this, but the more we're able to do that, and we're able to use AI in combination with a large database on the back end of the Creyos platform, and all this is happening in real time, of course, because everything's running over the internet. I think we're going to see some extremely powerful leaps in both accuracy and efficiency of assessment.
And now thinking about the application as it relates to personalized medicine, and this being kind of, again, for our healthcare providers on the session or attending the session, it's definitely like a rising and very, prevalent concept. How do you foresee cognitive assessment adapting to consider, again, being able to deliver that personalized care, and to consider the individual variations in healthcare settings?
Yeah, I think this relates to the last question, that, once you can really, well, we are now in a position where we can conduct cognitive assessments in individuals that are tailored for that individual, rather than just going into it as a sort of a generic, okay, here's, we're going to carry out a 3.5 hour WAIS-R because, that's what we do. Well, it's always struck me as odd, if you were assessing a patient with Alzheimer's disease or a patient with Parkinson's disease, you wouldn't give those two groups of people the same physical test to try and understand their physical challenges. Why would you just give them the same generic battery of cognitive tests? And, we're now, in a much better position to understand how cognitive function is affected differentially in different types of neurodegenerative diseases, after different type of brain damage, after different sort of in different neuropsychiatric disorders. And I think that means, I know that means that we can tailor the assessment to specific individuals. So, recently we've developed an ADHD specific version of the battery that it's basically being efficient again. What is the point in spending a lot of time testing somebody on things that are not relevant to the condition that they have? Isn't it best to really assess what we know are the cognitive elements or characteristics of that particular condition? And save time. It can be, massively efficient to do that. So that's one thing. I think specifically tailoring a battery to people's personal needs based on what it is they are struggling with, I think is really important. And similarly with things like longitudinal testing, again, it's sort of hard to do with traditional cognitive assessment to follow somebody longitudinally for a multitude of just basic practical reasons. Like often, there aren't multiple versions of tests, or if there are multiple versions, there's only 4 multiple versions. Well, what if you want to test somebody, every week for over the course of a year to try and map their decline into dementia? You're going to need an awful lot more than 4 alternate versions of a test. And one thing Creyos, I think, does very well is generate infinite numbers of new problems for people that it can be very useful for that. So yeah, I think personalized assessment is really important, and I think it's something that we're really getting much better at.
And so as cognitive testing becomes more sophisticated, whether it be through personalization, through AI, the combination of all of those things, put together, let's talk a little bit about ethics. What are the ethical considerations that emerge? I mean, we're getting much more narrow, much more focused, much more specific. How are researchers navigating these challenges with that, increasing level of sophistication?
That's a great question, Erin. And I could talk to you all day about this. I mean, the obvious thing, which I'll deal with very quickly, is data security. I mean, clearly, we live in a world where people are more and more willing to make their personal data available through things like social media, and huge corporations are often, as we know from what we've already in the news, are often using that data to their advantage. And that obviously raises many sort of thorny ethical questions that I think, we are going to have to deal with over the next few years. But I think something that's more relevant to, or more specifically relevant to cognitive assessment and other aspects of healthcare measurement is, what are we going to do as we get better and better at predicting outcomes? I think we have to be very thoughtful about how we serve up information to clients and other users of platforms like Creyos. I mean, just as a sort of a simple example, were we to get to the point that we could, say, be able to predict that somebody's apparent early memory impairments are going to progress to dementia with 100% accuracy, with a simple 5-minute internet test, if we get to that point, I think we're going to have to really think carefully about how we decide to impart that information to people. Now, fortunately, this is something that I've dealt with very often in my day job, because what I do, most of my research involves patients with very serious brain injury, and we work on improving diagnosis and prognosis outcomes in these patients, often using cognitive data. And often I have to sit down with families and break the news about what's likely to happen to a patient in the long term. Are they going to recover cognitively, or are they unlikely? The other extreme, are they even likely to survive? And I mean, typically, this sounds like an ethical minefield, but actually, typically, you'll find that most of the ethical issues that are associated with these types of conversations have actually been really well thought out by ethicists and philosophers and other sort of worthy people that know much more about this than I do, but in a different context. And what you'll find is that, I guess, sort of to make this really explicit, telling somebody that they've got dementia is not a new problem. This is something that we have dealt with, and we have standard procedures and methods for imparting information like that to a patient or to a family member. The fact that you establish that with a new type of technology to my mind, it doesn't change the fundamental ethical issue. And I think people will find that's actually true of most things. Although, we are coming up with new ways of doing things, new ways of diagnosing, new ways of predicting outcomes. This doesn't raise new ethical issues as long as we look back on how we've dealt with these things historically using more traditional approaches. That's certainly the case in serious brain injury, and I think it's probably the case in neurodegenerative diseases and other types of, for example, neuropsychiatric disorders as well. So yeah, there are many ethical challenges, but I don't think there are as many new ethical challenges as we might think that there are.
Got it. So now looking, we've looked a little bit at the past and what's transpired, and kind of certainly talked about, the rise of AI and some of the other initiatives that, happened in 2023. Looking ahead to emerging trends or methodologies, what do you see on the horizon for cognitive testing? Are there new areas of research that hold promise for advancing our understanding of cognitive function? What's kind of the next big
Right. Okay. Another great question. I'm going to try and not sound like a broken record here, but I think that I think the next big thing, it really is moving towards improved diagnosis and predicting outcomes. This is something I've worked in the field of cognitive assessment for almost 35 years now. It's something I've been very resistant to over the years. That is, ever saying, well, yes, you could use these tests to diagnose a disorder. But I think that the truth of the matter is, and sorry, just to add some flavor to that, the reason I've been resistant to it is that, just because a group of, say, patients with Alzheimer's disease are impaired as a group on test X doesn't mean that you can do what we call a reverse inference, which is that look at a single person's performance on test X and say that they've got Alzheimer's disease. And that's the problem. And that's a huge sort of scientific issue. It's something I've written about a lot, in the literature. However, that problem starts to, or that sort of theoretical or problem of logic actually starts to fall away as you get more and more people. And this is something that is happening. We have studies using 30 or 40,000 people with, for example, dementia going on using the Creyos battery. We have studies of many thousands of kids with ADHD. And once you start to get up to those sorts of numbers, you actually start to move in the direction where you can start to make, again, I'm going to avoid saying diagnosis, but I think you can make probabilistic predictions about outcomes. And I mean, our ADHD tool is a very good example where over the course of several years, we looked at the sorts of tests that within the Creyos battery that kids with ADHD are particularly bad at. It actually doesn't turn out to be the case that there are some, there's a test for ADHD and a test that doesn't touch ADHD because the brain doesn't work like that. There's no one-to-one mapping between a test and a disorder, but there are some measures within the tests that we found that, in this case, kids that were being diagnosed with ADHD were consistently poor at. And once you get enough of those measures, say if I give you, 15 scores that typically somebody with ADHD is bad at, and I were to report back to, you as a parent, well, your child scored, within the impaired range on 14 of those 15. Again, I'm not making a diagnosis. I'm not telling you that child has the ADHD, but I think you would walk away thinking you'd be able to interpret that if you have those particular characteristics on 14 or 15 factors, it starts to become closer and closer towards predicting how somebody is going to be diagnosed. And I think we're doing it with MCI as well, looking at people progressing to dementia. So, I don't think this is a fundamental change in theory. It's just the power of numbers. It's just once you get so much data that you really can look at, for example, 10,000 people who progressed from MCI to Alzheimer's disease and 10,000 who had signs of mild cognitive impairment that didn't go on to Alzheimer's disease, you can start to identify trends. And again, broken record, AI is going to be very important here because these are very big data sets and some of these relationships are very subtle. But I think this is an obvious direction we're moving in. I mean, just as a sort of a wrap-up comment, I think where things have really changed in 2024 is that I think the days of traditional cognitive testing are really over. And I've given you some of the reasons for that, and it still surprises me that many people are resistant to sort of giving up their traditional cognitive or neuropsychological tools. But would you use a 1950s edition of the Encyclopedia Britannica to learn about the current geopolitical situation? No, you wouldn't.
Right.
And I think we know an awful lot more in 2024 about the relationship between behavior and the brain than we knew in the 50s, 60s, and 70s when some sort of more traditional cognitive assessments were developed. And I think it's natural that we should take advantage of that new knowledge.
And so taking advantage of that knowledge, I think this is the last question that we have, and then want to make sure we've got lots of questions that have come in the chat, so I want to make sure that we have a chance to answer a few of those. How can healthcare providers incorporate cognitive testing into patient care? What have you seen work really well, I guess, and what are the opportunities to use it to enhance that patient experience?
I think we have a massive opportunity to involve patients and healthy populations in their cognitive and mental health. I mean, this has never been more of a focus than it is right now, particularly on, coming out of the pandemic. People are much more willing to talk about cognitive health and mental health than they ever were before. And if you think, what's happened over the last 30 or 40 years in the realm of physical health, I mean, when I was growing up, I don't remember there being any gyms anywhere. I certainly didn't have anybody in my life that ever went to the gym other than, physical education that we would do in high school. Whereas now, most people I know either visit a gym or they have gym equipment in their house. And, we've come to understand that promoting physical fitness or remaining physically fit to the extent that you can is beneficial for longevity, it's beneficial for health. And I think we can do the same thing with cognitive health, but I think it does have to be done in a similar way by encouraging people to care about their cognitive health. This is something that's easier and easier now than it ever was. I mean, if you look at what products like Fitbit and Apple Watch have done, have made people obsessed with counting their steps. It's a trivial example, but it's turned out that it's as a sort of a side effect of that. A lot of people are spending a lot more time walking around and trying to get their steps up. Why can't we do the same thing with cognitive health? Let's get people to care about their memory. Let's get people to monitor their memories or their ability to concentrate or their ability to solve problems and make decisions. Because just like physical health, the earlier you detect problems, the more likely you are to be able to mitigate the long-term consequences. And, if we get people into a sort of a headspace where they, actually monitor these things in the way that most of us now, will monitor our blood pressure or our heart rate or either ourselves or, through our family doctors. Let's get people monitoring their cognitive and mental health in a way that will allow them to alert us to when there are likely problems coming down the line.
Well, thank you for those very insightful answers to our questions. Now I want to make sure we leave about 10 minutes to answer some questions that have come in through the question section of the platform. So I'm going to start with one that is asking, how are neuroscience and clinical practice affected by new drugs that claim to slow progression of diseases like dementia? Obviously, this is a new development that came up, in 2023. How how is neuroscience and clinical practice affected by this?
Well, this is more of a political question, to be honest, than a scientific question, because, of course, there have been huge claims made about some of these anti-dementia drugs, and there are some companies, I'm not going to name any names, that are actually being hauled through the courts right now about making unsubstantiated claims. And so actually I think where the role that neuroscience really plays here is in trying to control the narrative a little bit, to make sure that it stays as close to the scientific truth as it possibly can. One understands the temptation to go out early, with a sort of anti-Alzheimer's drug, because there are billions and billions of dollars involved in making these, or that potentially can be made from making these claims. But I think the role that actually, I think with cognitive assessment at Creyos, we have a very important role to play here, which is to make sure the public is properly educated in how these potential changes, or the changes that are being described, translate into real clinical differences. I don't want to go into too much detail about particular instances that I have been involved with or have been asked to comment on, but what often happens is that legitimate claims are made about improvements based on drugs, but they get served up in a way that unfairly represents what that would mean for an individual. A very obvious example is group studies. It's an obvious sort of scientific example that when you show that as a group, group X of patients significantly improved relative to a group of people on placebo, for example. And that's all very well, but what's really important from a patient perspective is to say how does that translate into an individual? Does that mean every individual is actually going to get better, or does it mean that some people are going to get better, some people are going to stay the same, and maybe some people will get worse? So that's a piece of information that is often obscured within the behind the headlines. And the other is, what does that change in performance actually mean? A very good example is where people say, well, there were significant improvements in this memory test. Well, if that improvement equates to being able to remember on average 0.2 more digits in a digit span task, that may be something that is not really not clinically significant. And I don't mean that in statistical sense. I mean that in the sort of descriptive sense that, yeah, sure, it's a statistically significant result, but it's not actually going to change anybody's lives. So sorry, a long answer to your question, but I think this is where we as neuroscientists and we as a company like Creyos really have to stand our ground and make it very clear in the way that we communicate results to the public, what they really mean in terms of how they affect individuals.
Makes sense. And I guess going on the vein of communication, somebody's asked a really interesting question. Consumers are wary of AI results, and there's a little bit of trepidation around AI and what it can do. In your opinion, what can scientists do to help people get past that prejudice and embrace AI a little bit more, maybe than they've historically been willing to?
Yeah, that's a really great question. I think the answer is probably to stop using the term AI to cover a whole multitude of things. Because, when people often, use the term like AI, they start thinking about, robots and bots that can, do stuff and behave like humans and all that stuff. But actually, a lot of, techniques that come under the general umbrella of AI are basically just high-end statistical methods. And also not new. What is new is that we now have the computing power to carry them out. So, this is why I was quite careful when I was answering your questions to refer to the techniques that we've been using in my lab as machine learning, because machine learning is, it's not a new technology. It's not some new thing that's just been created in the last couple of years. It's been around for a very long time. But if you want to apply machine learning techniques to cognitive data from 100,000 people, all of whom did 12 tests and had 42 measures, that suddenly becomes quite a tough computational problem. And it's only a problem that we've been able to solve in any reasonable time frame in the last few years. You know, up until maybe 4 or 5 years ago, it would only be something that could be done with extremely high-end computers that fill rooms, and whereas now you can virtually do this stuff on your phone. So excuse me. So that's what's really changed. So I think sorry, a more succinct answer to your question is the problem is so much is pulled under this sort of umbrella of AI, and there are scary things about AI, and I understand why people are scared about people's jobs being taken away by robots and not knowing whether you're talking to a real person or a bot on the end of a Twitter feed or whatever. But there are a lot of parts of it that are not at all scary and are just sort of nuts and bolts. You can think of them as new technologies that we can use to either speed up things that we used to do manually, or indeed do things that we would have always liked to have done, but are just much more efficient now with improvements in computer technology. So not all AI is the same. I guess that's my message.
Yeah, I think the marketer in me is saying AI maybe needs a little bit of a rebrand in the sense that it needs that clarification around what it is and isn't.
Well, it's difficult because there's a sort of allure of, you see it every day in newspapers that AI was used to do this, AI was used to do that. And it's, it sounds much more interesting if you call it AI, but, as opposed to we used a 4-decade-old statistical technique to solve a problem we've been wrestling with. It doesn't sound quite as exciting. So I can see why it gets labeled this way, but it probably, isn't beneficial for the field as a whole.
And really quickly, because we're coming up to time, the last kind of minute or two that we have left, what do you have coming up in your lab? What are some of the things that you and your team are about to be embarking on in 2024 that you are excited about?
Oh yeah. Again, I could talk for 2 days about this.
That could be its whole own session.
it could be. So actually, the most exciting thing that we did last year, I already mentioned, which was we used a machine learning technique to accurately predict who was going to recover from a coma and who wasn't. Now, the reason that was so exciting for me is that it was 10-year-old data we were working with. Mm-hmm. We went back to an old data set that we'd actually published 10 years ago, and we'd published as, well, here's some interesting data, but we can't predict outcomes based on it. We took that and we said, okay, well, maybe with current machine learning technology, with the computers that we have today, maybe we can actually find patterns in here that will make predictions. And bingo, it worked at least beyond my wildest dreams. And I think this is a direction we're really moving in with the cognitive data as well. We have these huge data sets over the last 10 or 15 years, through the Creyos platform, we've collected, I think, something close to 14 million data points now. We have, beyond the normative database, we have millions of sets of data from various studies we've conducted, from various large-scale populations we've recruited. And I think that data is really ready to be mined. Mm. And I think we're going to find some, fascinating relationships between things like lifestyle factors and cognitive performance, making predictions about the early onsets of disorders, what they look like cognitively, and these sorts of things. And I'm really excited about this because I think we're going to be able to crack a lot of new and old scientific problems.
Okay, well, that takes us to the end of our session. I know we didn't get to necessarily everybody's questions. We will try to follow up with folks where we can to provide answers offline so that we don't leave anybody hanging. If you want to get more content like this, read more about Professor Owen and the work that his lab is doing and the research that has been incorporating tools like Creyos, please feel free to connect with us. You can contact us at one of the 2 email addresses you see on the screen. You can visit our website at creyos.com. And we are, of course, on social media, so feel free to follow us on Twitter, LinkedIn, or Facebook. We will be conducting more sessions like this throughout the year, both with Professor Owen in an interview style, but then also doing some panel conversations with other experts in various fields of healthcare. And so we encourage you to continue to watch for invitations and to tune in to us next time. Thank you, everybody, for joining.